Good evening, students. Today I am going to teach you guys the chapter 2 exercise 2.1, that is polynomials, class 10th NCERT. First question in exercise 2.1, only one question is there. In this question there are 6 parts. We have to let's see what is the question is. The graphs of y is equal to p of x are given in figure 2.10 below for some polynomials p of x. Find the number of zeros of p of x in each case. So we have to find the number of zeros. I would just like to say a trick over here. We have to just check whether in the given graphs given, how many times does the curves or lines intersect. That is equal to the number of zeros. So moving on, in the first case over here we can see that the line is parallel to x-axis in case of first one, hence there are no zeros. So you guys can write as number of zeros is equal to 0 over in case of first case. And similarly, let us see for second case. Over here in case of second case, only one time the graph or the curve in the graph mentioned is intersecting the x-axis. So in case of second case, the number of zeros is one time. And in case of third part, over here we can see that 1, 2, 3. We have 3 times intersection, so there are 3 number of zeros in case of third graph. In case of fourth part, in case of fourth case, there are 2 intersections in of the curve with respect to x-axis. So the number of zeros is 2. In case of fifth graph, here we can see that 1, 2, 3, 4 intersections. So there are 4 zeros in case of fifth graph for p of x. And in case of sixth, we can see that 1, 2, 3. So totally there are 3 zeros in case of sixth part. Thus the answers are completed. Thus I have solved all the 6 parts. Moving on to the exercise 2.2 now. So now I'm going to solve exercise 2.2. Before moving on to the exercise 2.2, I would just tell you guys a concept which will be very helpful to solve exercise 2.2. So first question is, among this, find the zeros of the following quadratic polynomials, and we have to verify the relationship between the zeros and the coefficients. So first question in this is x square minus 2x minus 8. So we have to, as a first step, we have to split the middle term such that it adds up or subtracts up. It can be any operation. It should be equal to coefficient of, here it is 1 into, here it is c, that is constant term is minus 8. It should be adding to minus 8, or when we multiply both these terms, we should get minus 8. And also similarly, we should get minus 2 also. So we know that 4 2s are 8, and minus 4 plus 2 is equal to minus 2 itself. So have written as x square minus 4x plus 2x minus 8. So simplifying now, again in these terms we have x as common, so x into x minus 4, and over here it is plus 2 into x minus 4. So we can now write as it is x plus 2 and x minus 4. So equating x plus 2 is equal to 0, we get x is equal to minus 2. Similarly, equating x minus 4 is equal to 0, we get x equals minus 4. So the values of zeros are minus 2 and minus 4. Sorry, over here it is plus 4. So the values of zeros are minus 2 and 4. So we know that now the zeros are minus 2 and 4 for this first part of the first question. And now we should verify the relationship between the zeros and the coefficients. So we know that sum of the zeros, that is, let's say alpha and beta in general, is equal to minus b by a. So now we have to add both these zeros. We have got 2 plus 4 is equal to 6, right? So the zeros are 4 and minus 2. So minus 2 plus 4 is 2, right? So this is equal to, we know that minus minus of 2 by a is 1. So it is equal to minus 2. This and the coefficient in the equation are same. So this is verified. That is, sum of zeros are verified. Similarly, product of zeros alpha beta is equal to c by a. So two into, that is minus 2 into 4 is 8. So we know that c is 8 and a is 1. So this is also verified. Moving on to the second question. So second part of this question is 4s square minus 4s plus 1. So we can simplify 4s square minus 4s plus 1 as 4s square minus 2s minus 2s plus 1. So in this first two terms we can take 2s as common. 2s into 2s is 4s square minus 1 and minus 1 into 2s minus 1. So this is the factorized part. If we simplify this and write, we can write as 2s minus 1 in to 2s minus 1. So thus we get 2s minus 1 0 is equal to 0, or 2s minus 1 is equal to 0. When we equate it to 0, we get s is equal to minus 1 by 2, and again we get s is equal to minus 1 by 2. These are the zeros of second part. We know that zeros are 1 by 2 and 1 by 2. Now to verify that alpha plus beta is equal to minus b by a, we know minus b. So minus of, we know that it is minus 4 in the question, by a is 4. So which is equal to 4 by 4. So which is equal to 1. And we also know that 1 by 2 plus 1 by 2 is equal to 1. Hence sum of zeros is verified. Similarly, for product of zeros, it is alpha times beta is equal to c by a, that is constant term by coefficient of x square. Over here it is s square. So alpha beta means, so it is 1 by 2 into 1 by 2, which is equal to 1 by 4, and c by a is also 1 by 4, and hence second question is also, it is verified. The relationships are verified. So when we multiply the first and last term, so we get 18 minus 18. So we have to split the middle term in such a way that we get minus 7 when added. So 6x square minus 9x plus 2x minus 3. So when we furtherly move, we can rewrite it as 3x as, taking 3x as common, into 2x is 6 square minus 3 minus 1 into plus 1 into 2x minus 3. Hence simplifying, we get 3x plus 1 is equal to 0, or 2x minus 3 is equal to 0. Hence we can write 3x equal to minus 1, or x is equal to minus 1 by 3. Similarly, we can also write 2x equal to 3, or x equal to 3 by 2. So we get the 0 values as minus 1 by 3 and 3 by 2. Let's check with the relations. In case of sum of the sum, minus 1 by 3 plus 3 by 2 is nothing but so it would be equal to 7 by 6. And here in this question, we get it as minus 7 by, we know that minus of b by a, here it is minus plus alpha beta is minus 1. So the answer would be it is plus over here. The answer would be, after simplifying, when we take 4 common and we take the LCM, it would be 4x square minus x minus 4 equal to 0. This is the answer for the first part of the second question. Moving on to the second question. Second part of the second question. In second question, the sum of the roots is 2 and product of the zeros is 1 by 3. So it would be x square minus 2x it is root 2 in case of second question. So it is minus root 2x plus 1 by 3. So when we take the LCM, it would be 3x square minus 3 root 2 x plus 1 equal to 0. This is the answer for second part. Moving on to the third part. In case of third part, given that sum of zeros is 0 and product of zeros is root 5, and hence it would be x square minus 0 times x plus root 5. Which is equal to 0. The fourth part is 1 and 1. So sum and product of zeros is given as 1. So we can frame as x square minus alpha plus beta is 1 times x plus alpha beta, that is product of zeros, is 1. So hence the polynomial would be x square minus x plus 1. Moving on to the fifth part. It is given that sum of zeros is minus 1 by 4 and product of zeros is 1 by 4. Hence the polynomial or equation would be x square minus of minus 1 by 4 times x plus 1 by 4. So simplifying, we get x square plus 1 by 4 x plus 1 by 4. So when we take LCM, we would get 4x square plus 1x plus 1, which is nothing but 4x square plus x plus 1. Hence, this is the answer for this part. Moving on to the sixth part. Sum of zeros is 4 and product of zeros is 1. So x square minus sum of zeros is 4 into x plus product of zeros, it is 1. So the answer is x square minus 4x plus 1. So thus the chapter is completed. Thank you all. Keep visiting my channel and subscribe for more updates.